Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is like find if the path exists in this particular graph. So we are given a bidirectional graph. That means we can move like from 0 to 1, and then we can move from 1 to 0, and then which contains a n integers, which n vertices, which will be labeled from 0 to n minus 1, and then it is going to be inclusive. And then we are given edges of I, which means ui will have a edge with vi, and then vi will have a edge with ui. And then we are also given, we need to find this particular valid path, whether it exists from source to destination. Suppose let's say we have this particular graph, and then we need to find whether there is a path between 0 to 1. Then we can say that that is true, so we are going to return true. And then if we have source as 0 and then destination as 2, then we are going to return it as true. So if we come to the implementation of this, we need to find whether this particular valid path exists between source and destination. So let us take one example where we have this particular graph. This is disconnected graph. Why? Because it contains 0, 1, 2, and then 3, 4, 5, which is disconnected. It doesn't have the connection between these two components. And then let's say we need to find the source. Let us take source equal to 0 and then destination equal to 1. Now when we say source equal to 0 and then destination equal to 1, then we can say that it exists. The path between 0 to 1 is exists. And then for this we are going to return as true. And then if we come to the 0 to 2, it exists. So we are going to return it as true. And then if we take source as 0 and then destination as 3, then we can say that the path between 0 to 3 doesn't exist. So that's why we are going to return as false. So the idea is going to be like this. So we are going to take the source, and then we are going to take the source in the queue. Suppose let's say we have a queue, and then we'll take it as 0. And then now we'll take all the nodes which are connected with this 0. That means it is going to have 1, and then it is going to have 2. So that's why we are going to push 1 and then 2. And then afterwards we are going to check whether there exist any nodes between 2 and then 1. Suppose let's say we have here 6 and then 7, and then for this we have 8. Now I'll take 1, so I'll pop 0 out of this because it is visited. And then I'm going to take 1 and then 2. Now let's say the destination is 7, so I'm going to take out 1 again, and then I'm going to check the the adjacency edges with this particular one. So we are going to have 0 as well as 8. So if we again push 0, then it is going to be a problem. Why? Because 0 will again call 1, and then 1 will again call 0, and then it is going to be infinite loop. So we need to make sure that this particular node is visited. So whenever we are taking this particular queue, and then we are picking this particular node, then we are going to mark it as visited. So if it is visited, we are not going to push into the queue. So we are going to push only 8, and then we are going to pop 1. And then after this we are going to take 2, and then we are going to push all the adjacency elements which are not visited. So we are going to push 6 and then 7. And then after this we are going to check with the 8. So 8 as a edge 1, but this is already visited. So we are going to take out this 8, and then we are going to take the 6, and then it doesn't contain any adjacency element. It contains a adjacency element 2, but it is already visited. So we are going to take 6, and then we are going to take the 7. Now 7 is a destination, so we are going to return it as true. So that's why we are just going to traverse the, like, in breadth first search. Suppose I'll take these elements which needs to be pushed in the queue, and then again I'll push the second level, and then again I'll push the third level, and then again I'll push the fourth level. It is going to be like level by level. We are going to pick the elements, and then we are going to push the adjacency elements which are not visited for this particular node. And then at last, whenever we find this particular node to be destination, we are going to return as true. If we did not find the any destination and then we are completely done with the component, then we are going to return as false at the last. So let us see the code for this. So we are going to take visited array, which is going to be consisting of 0 to n elements, and then we are going to mark it as not visited as of now. And then we are going to build this adjacency list. That means we are going to build from u to v, and then from v to u. Suppose let's say we have different edges. We need to consider, suppose we have 0, and then for this it can have the edges between 1 to 2 and then 3, and then 1 can have between 3 and then 4 and then 1. So we need to build this particular adjacency list so that whenever we want to get the adjacent vertices, we are going to pick from the adjacency list. So we are going to pick from adjacency, we are going to pick from edges, and then we are going to push into the adjacency list, and then we are going to mark this particular source as visited, and then we are going to push into the queue. After pushing into the queue, we need to pick this particular node, and then we are going to pop this particular node. Suppose let's say if this particular node is destination, then we can reach this particular destination by starting with this particular source. That's why we are going to return as true. And then for each node, we need to see the adjacency nodes which are present in this particular node. And then if this particular node, which is the adjacency node, is not visited, that means we need to visit this particular node, as well as we need to push into this particular queue. And then after we are done with this queue, if we did not find any destination, we are going to return as false. If we find any destination, we are going to return as true. So if we come to the time and space complexity, the time complexity is going to be big O of n e, and then the space complexity is going to be big O of n and then e. Why? Because we are considering this adjacency list where it contains n nodes and then e edges, and then for the time complexity we are going to push, uh, for the space complexity it is going to be n plus e, and then this time complexity is going to be n plus e. Why? Because suppose let's say I have an one node, and then for this particular one node I'm going to take all the edges which are present with this particular one node, and then if I come with the second node, then I'm going to consider all the edges which are adjacent to that particular node. That's why we are going to consider all the vertices as well as the edges. Yeah, that's all for this video. Thanks for watching the video.